In the previous lecture, we created a new class that has 4 members that do the exact same thing that we did before, which are add, subtract, multiply, and divide. And we started using it inside of the main method from the program class. We also defined another class in a new folder, which allowed us to identify the difference of namespaces and what is needed in case of this using directive for us to be able to use the members that are inside of this namespace. For example, the bank account. So far, we have been using a class with static elements that mean that we do not need an instance or an object of this class to be able to use its members. But we talked about the simple math not needing an instance or an object because its members work alone by themselves. They don't really need anything else. The add method is just going to add 2 values that we can pass from outside of the class, and nothing else is needed. But for example, let's go to the bank account and define a couple of variables. Let's define a public float balance variable, and let's define a public string owner variable. In this case, it's obvious that this is going to require information from outside of the class, because not every time is the balance going to be the same or the owner going to be the same. Because this is about, for example, a bank account. Not every bank account is the same, so we'd need to create objects, each of which would have a different bank account reference to it. We can also think of this when defining a public float add balance method that is going to receive float balance to be added. And we define the body. And this method will return the current balance, which is balance, plus the balance to be added. And we know about the balance to be added because it is received by the method. But what about the balance? What's its value? What's its value currently? Well, it would depend on the object in which it is defined. Let's go ahead and create 2 new objects of type bank account, meaning that we are going to be creating 2 instances of the bank account class and use the add balance method. Let's navigate back to the program file, and inside of the main page we can start writing bank account. And we have access to it already because we added the using directive to its namespace. But if I type dot, notice that I do not have access to its members because they are not static. The way to use them can only be performed through an instance. So let's create an instance of a class. To create an instance of a class, all we have to do is write the name of the class and the number of the object that we are going to create. In this case, we can just call it bank account 1. And we are going to assign a value to this, which is going to be new bank account, and we're going to close parentheses. This is how you define an object. You can see that it is pretty much a variable. It has a type, it has a name, and it has a value. The interesting thing in here is that the type is a class that we have created ourselves, and the value is going to be a new instance of the same class. And we're using this parenthesis, and we're going to take a look in just a second. But once we have this instance, we can type bank account 1 dot, and notice that now we have access to add balance, we have access to balance, and we have access to owner, as well as another couple of members that needed the class to be instance to be able to be used, meaning that they were not static. Let's start, for example, by setting the owner for this bank account, which is going to be Jane Doe, and we can set the bank account's balance to be equal to some random number. And this is float, so I have to add the F at the end of the definition. And then we can create another bank account. I will just copy this definition and change the name of the bank account that is being created, in this case bank account 2. And I will set its owner to be John Doe, and its balance is going to be less. These are now 2 instances of the bank account class. Each instance has its own values. They exist by themselves. So for example, I can try this, I can test this by writing something in the console. And what I want to write is what happens when I add something to the balance. In the case of the bank account 1, what happens when I add 100 to the balance, and the same thing but with the bank account 2. This should return two different things because one instance has a lot of money and the other instance has way less money. So adding 100 to each of these balances will return a different thing. I am calling the same method from the same class, but these are two different instances, each of which have different values inside of their variables. So the value should be different. I am going to run the application on the console and notice the difference. We are still seeing that first evaluation from the division, but this would correspond to the first bank account. And it is definitely the value that we said before plus 100. And the second is returning the value for the second bank account 2. The balance is different, the addition is different. Again, it's the same method, the same class, different instances. Now let's talk about this syntax right here. We are creating a new bank account and we have some parentheses. This looks a lot like the calling of a method. And in fact, a method is being called. By default, every class has a constructor method. Like its name suggests, is the method that is going to create an instance of that class. And by default, there is a constructor that doesn't require any arguments. That's why we didn't pass anything between these parentheses. And it doesn't even need to be defined. It just exists implicitly. But we can define our own constructor. Constructors are usually defined between the variables that are inside of the class and the other methods. So the constructor should be the first method to be defined. It won't really affect the functionality, this is just good practice. To define a constructor, all you have to write is type CTOR and tap on your keyboard twice or write it down. This method will not have a type. It's just a public, it always has to be public, and it has the same name as the class. By default, it receives no arguments and we add no code inside of it. This is the default constructor, the one that doesn't need definition to exist. It just exists implicitly. But we can define our own constructors. And if we define a new constructor in here that receives arguments and that has some body, then the default constructor will cease to exist, unless we define it ourselves. What I mean is that I can have another constructor that receives a float, which is the balance, and a string, which is the owner. And inside of the body, it is going to set the local balance. By the way, to access local variables, we can use the this keyword. So we can access the balance and differentiate it from the balance that we are receiving inside of the arguments. So this balance, notice that it refers to the balance being received by the method, and this other balance refers to the class balance. And then we can access the owner and set it to owner. So we have now two constructors, one that receives the balance and the owner, and one that is the default constructor that receives nothing. And because there are now two different constructors, we can use them when creating a new instance of the bank account class. Notice that when I type a parenthesis when using this bank account, Visual Studio tells me that there are two constructors that I can use. And if I use my arrows, I can check them out. One, the default constructor that doesn't receive anything, and another that requires a float and a string. But let's say that we don't want the default constructor. In fact, for a bank account, we absolutely need the balance and the owner, so there is no use in creating an empty bank account. So we don't need the default constructor. We always need the balance and the owner. So we erase the default constructor, and because we have another constructor, then the default constructor does not exist, and we see some errors in here. Because if we write the parentheses, we now only see one constructor and it is requiring a balance and an owner. So let's set the balance for these two instances right from the definition or from the creation with the constructor, as well as the name. And so we do not need these two elements anymore because they are already being defined from within the constructor. And the same thing for the second instance. And we do not need these two variables. In fact, if you think about it as well, we should not have access to these variables because we do not want to be able to change them. So we can define them as private. This way, we no longer have access to them from other classes. If I wanted to access the bank account's balance or owner, we cannot do it directly. We can still perform the operations because it is performed inside of this class, and of course the same class has access to its own members, but we do not have access to them directly. So let's go ahead and test this out again, and notice that the result is the same. We are still able to perform the addition into the starting balance for these bank accounts, but we no longer have access to those variables directly. We have started to create objects, and we have used its constructor to do so. This has allowed us access to the members that are not static. And we have also created another constructor which overrides the default constructor and in fact gets rid of the default constructor. That absolutely makes it necessary for instances to define certain values. For example, in the case of bank account, define its balance and define its owner. In the next lecture, we're going to start taking a look at properties. In the case of we want to get access to these private variables securely, so the user cannot change the balance of the owner, but maybe they can read it. We're going to take a look at that in the next lecture.